are listen-only mode.
Hi, everybody. Thank you for being patient with us as we worked out some internet issues. This is Ellen Gunlack from Purdue University, and I would like to welcome you to our CAUSE Teaching and Learning webinar on sampling variability, a hot topic in the Common Core. Our speaker today is Anna Bargagliotti from Loyola Marymount University, and I want to remind you that you will all be muted, and if you have questions, just type your questions into the question box, and I'll be sure to ask Anna when we get to a good stopping place. Anna, go right ahead.
Thank you all, and thank you so much for being patient. I'm so sorry. I seem to always have technical difficulties at the wrong time with these webinars. Anyways, well, I will get right started. So as we have all been hearing lately, there's been a real strong push for increasing statistics education for K-16 and in particular K-12. The Common Core state standards for mathematics include a large amount of stats at the middle grades and the high school grades and a smaller amount at the elementary school level. The MET reports, MET 1 and MET 2, have identified stats as a large area of concern for teacher preparation. So at the elementary level in the Common Core, there's a small amount of statistics in the measurement and data strand. At the middle school level, there's a large amount of statistics introduced. And then at the high school level, stats is pretty much, it depends on what the type of curriculum or what type of structure the high schools have, but it can be interwoven in all courses. It can be in a standalone AP course, in a standalone non-AP course, which is becoming more popular, and also within the modeling strand. So this offers us great challenges and opportunities. The increased attention towards statistics is welcome and needed. This provides huge opportunities for us, and particularly for statistical learning in the general population. However, with these opportunities, we also have a great challenge. One of the main challenges that I think is the preparation of teachers in statistics, and that's what I'm going to kind of focus around today. At the pre-service teacher preparation, at the elementary levels, teachers take at best 3 courses in mathematics departments and possibly only 1 chapter or unit dedicated to statistics. At the middle school level, teachers may have more math courses, but they may only have what the elementary teachers have in terms of statistics. Or at the high school levels, teachers typically are undergraduate math majors or math minors, during which they may or may not have a statistics course, depending on sort of the program, the undergraduate program in itself. That's pre-service teacher preparation. In-service teacher preparation looks, in some sense, even worse. In-service teachers, current in-service teachers, were mostly trained before the Common Core implementation, so little to no statistics may have been present in their teacher preparation at all. And there's really a large need to help both in-service and pre-service teachers with the preparation. And I should make a note that their needs are actually quite similar because their preparation is similar. So now we've been talking a little bit about this emphasis in statistics in the Common Core. So what are the topics that the Common Core emphasizes? Well, one of the main concepts is sampling variability, which we're going to discuss in detail today. And some other topics to give you an idea if you haven't had a chance to look at the Common Core include bivariate data analysis, probability as used in decision making, and also distributions. And today, from here on out, we'll focus in on sampling variability and the work we've been doing with sampling variability through Project SAT. So sampling variability, as defined as the variation of a statistic found from taking random samples repeatedly from a population, is a central concept in stats. Gase suggests teaching sampling variability in the middle grades, or introducing it in the middle grades, and continue it through high school. And the Common Core addresses sampling variability in middle school and high school grades. So what does the Common Core look like in terms of sampling variability? So in grade 7, there are 3 standards that really sort of hit sampling variability, and they are: use random sampling to draw inferences about a population, draw informal comparative inferences about 2 populations, and then within that there's a sub-bullet that says use measures of center and measures of variability in random samples to draw informal comparative inferences about 2 populations. And a third bullet or a third standard in grade 7 is investigate chance processes and develop, use, and evaluate probability models. And a sub-bullet for that is to approximate the probability of a chance of an event by collecting data on the chance process that it produces and observing its long-term or long-run relative frequency. So all these three standards and their sub-bullets to some degree contain this concept of sampling variability, sampling distribution sort of in the background. Then we get to high school, and in high school we have two main standards that address sampling variability: understand and evaluate random processes underlying statistical experiment, and making inferences and justifying conclusions from sample surveys, experiments, or observational studies. Underneath that standard, there are three substandards saying use data from a sample survey to estimate a population mean or proportion, developing a margin of error through the use of simulation and random sampling, understand statistics as a process for making inferences, and decide if a specified model is consistent with results from a given data generating process. So these are quite a lot. If you consider all of the statistics standards from, let's say, the middle school grades all the way through high school, it's quite a lot to have 5 standards sort of focus on one type of real topic or concept. Oops. Okay. So in light of this, and in light of the Common Core emphasizing sampling variability, it's very important for our teachers to have a good understanding of the topic in order to be able to effectively teach their students and meet the requirements. So to address this specific need, this teacher need, Project SET aimed to develop professional development materials for teachers to learn about sampling variability. Now what we did first was develop a hypothetical learning trajectory, which I'll refer to as an LT. I'll refer to learning trajectories as LTs throughout, along with the activities and assessments to be used to teach and test teacher understanding. And then we tested this learning trajectory and the accompanying materials in 2 pilots with high school teachers, and then edited the materials accordingly. Now, what I wanted to do now is I hope that you were able to sort of download or have in front of you or on the screen the 2 learning trajectories. So I wanted to show you a before and after the pilots learning trajectories. Let me see if I can put them up both on my screen next to each other. So the one that's dated 12/10/5, that one there is our original learning trajectory. So before we started the pilot, the first pilot, we had an extensive sort of iterative process that discussed, let me get back to that, sorry. So the development of our learning trajectories was an extensive multi-year process, and it underwent several iterations within our project team. And then after all these iterations of these several years, in these 2 years, we went and piloted it. And after each pilot, and then it's been significantly edited. So you should have the before and after versions of the learning trajectory. And the after version says the June 2014 at the top. And I'll go through them in a second and pull them back up. But you should also just have note to self that the after version, which is really, I should say, the current version, the 5th loop or a portion of it is still undergoing some edits, as the second pilot is just at this point right now. So in other words, our second pilot group of teachers finished this learning trajectory last week, and we're in the process of analyzing this last sort of data from the pilot, and then should have the real final one next week for everybody up. So I wanted to take a little bit of time to sort of go through this and show you what we did. And I also wanted to say, I don't know how many of the listeners have a lot of experience with learning trajectories or not, but there's a lot of different types of learning trajectories, if you will, and this is definitely our take on it. So, you know, different learning trajectories may look differently. So what we did is, you can see in the columns, and this actually, this structure actually stayed from the before to after. Okay, so our columns are the GACE framework: formulate questions, collect data, analyze data, and interpret results. And so what we essentially did was try to unpack what teachers would need to do in order to have the goal in mind of having a greater understanding or an understanding of sampling variability, sampling distributions, and being able to take it all the way to inference to confidence intervals. And what does that look like in terms of progressing content-wise? So the loops, the horizontal, the rows, represents they represent the processes that a teacher would have to go through. So in other words, they would first start with loop 1, go through the GACE process for loop 1, come out. If they progressed through that just fine, they would go on to loop 2, progress through that, and then go on to loop 3, progress through that, and then keep going down to loops 4, 5, and 6 in the original. And so when you look at the original, we had those 4 columns with the GACE framework, and we had the loop structure, which we really liked and worked well, we thought, with this particular topic, because it was such an iterative kind of going over things and building. Then in our final learning trajectory, or I'll call it final for right now, you'll see it looks quite different. So from our first pilot, we changed, we drastically changed the learning trajectory to better address the teacher needs. One of the main things we did was add this column at the end of key developmental understandings, where at the end of each loop, we actually have in our minds the learning trajectory structure in the background of these were the main points that we wanted the teachers to get out of that particular loop. And you see that they continue, that yellow column continues throughout all of the loops. So let me go back up. The other thing we did, the other main big, very large, drastic change from the first version to the second, to the end version, which is, I would say, is possibly the 10th version, is that formulate questions column also drastically changed. What we really did was we tried to, in this newer version, which we're going to call our final version soon, is we tried to really put questions in that drove the loop and drove the content of the loop. Whereas before, we started off with just saying, oh, well, the class would just have to formulate a question for this to happen. And instead now we actually have the questions very well, these guided questions very well explicitly written, and they match very well with the key developmental understandings. So I'm sure there's going to be questions about the learning trajectory, and we'll go back to that, I think, when we talk at the end in the question time. But in the meantime, I just wanted to sort of give an overview of the structure of the learning trajectory, because I know it's kind of a lot to look at when you're not used to seeing it. So let me go back to my full screen. Okay, so what did we do to test these learning trajectories? Well, our first pilot was in Memphis, Tennessee with 9 teachers. And our second pilot is in Los Angeles with 4 teachers. The pilots met for 15 weeks for 3 hours each time. And what we did was we dedicated one of these class periods, let's say, one loop was covered in one class meeting. So therefore, our final learning trajectory right now that we have for sampling variability has 5 loops. So there were 5 class periods dedicated to sampling variability. So that's a total of 15 hours. For each loop of the learning trajectory, we developed one activity that teachers would work through during the professional development to guide them through the knowledge in the loop. And then also for each loop, we developed one open-ended assessment task that aimed to understand whether the teachers actually went through the loop and understood all the key developmental understandings of that loop. So and let me say 2 quick things. So for the activities, all of our activities from the first pilot to the second pilot, after the first pilot, the activities were drastically changed, a lot of them, and the approach was really changed in order to address the teacher needs. And in general, the activities are pretty self-guided, meaning they are meant to have minimal lecture surrounding them, so the teachers are really working through them actively on their computers through technology or by hand, depending on what the activity is, and then we're coming together as a group to discuss their answers. But there's there's very little instruction of me, let's say, or whoever's teaching it, standing up at the board and lecturing. Now, one thing that we uncovered in the open-ended assessments from the first pilot was that teachers had several misunderstandings. And so what we did is we took those understandings, and I'll show you on the next slide some of them, what they were, and made edits to the learning trajectory, the activities, and the assessments accordingly to address them. So in other words, we tried to address them not only more explicitly, like for example in that formulate questions, we really tried to make things very clear on what we meant for the learning trajectory, but also the activities themselves were now very structured around those key developmental understandings, and in such a way that we were trying to ensure that the misunderstandings would not come about. And in the second pilot, the learning trajectory is presented to the teachers after the completion. So here are some of the misunderstandings that we uncovered. We uncovered misalignment of a statistical survey question with the goal of a study. Teachers fixating that the mean and the median are the only two possible numbers that can ever describe the center of a distribution. So I'm not going to go into this today, but Randall Groff and I discussed those during our ECOTS presentation. So if you're interested in those particular two, you can listen to that presentation. That should discuss it. Teachers had a really hard time confusing population distributions, sample distributions, and sampling distribution. They had several misunderstandings about the central limit theorem, and one of the big ones was that they believed that the mean of the sampling distribution approached the mean of the population as the sample size increased. So they were putting this approaching in, which is not in the central limit theorem, let's say. And the last one is misunderstanding that multiple samples are needed at all times in order to say anything about a population. This is a particularly interesting one to me, as I think there's been several studies even discussing this at the undergraduate level, that this is something that we deal with all the time as a misunderstanding. And also, I believe Nathan Tintola and Beth Chance actually mentioned this in their ECOTS presentation or ECOTS workshop about this as a concern also for doing the simulation-based methods, is will this actually perpetuate this misunderstanding? So I think this is a particularly important one to discuss. So what we wanted to do for the materials, and what we've tried to achieve with the materials, and I personally think that we're getting pretty close once our final ones are up this summer, is we wanted these PD materials to be off the shelf. So that means anyone can pick them up, even people that are not, don't have a really strong statistical background. So we recognize the fact that people doing teacher training or teacher professional development are not always statisticians. And they don't always teach statistics courses, even at the undergraduate level. So this necessity to provide materials that are sort of self-contained and off the shelf in such a way that shows, for example, a mathematician what the structure would be is a main goal of ours. So therefore, for us, it's very important that the activities and the assessments and the learning trajectories take into account any common pitfalls the teacher may fall into. And after this first pilot, we drastically changed the approach of several of the activities to ensure that we were actually not creating any of those misunderstandings that we pulled at. So I wanted to show you briefly one activity that promoted many aha moments during the second pilot. This activity was very much changed in the approach from the original one in order to ensure that we did not lead teachers to confuse the population distribution, sample distribution, and sampling distribution, and also misunderstand that the mean approaches the population mean. So here's the activity in brief, basically. We give the teachers 4 different people, kids, Sally, Jamal, Ivy, and Tom. And they pull their text messaging data from their carriers, and their data is for 3 years, so they have 1,085 days in each data set. And the data sets, each observation is the number of text messages received or sent in one specific day by these 4 kids. So each group of teachers is given one person's text messaging data. And for their assigned person, each of them finds an approximate sampling distribution for the mean text messages using samples of different size 10, 30, and 50. And then they're basically asked to comment on the center shape and variation of their approximate sampling distributions, and then compute the means and the standard deviations for the sampling distributions, which then at the next lesson would lead us into the derivation of the standard deviation for the sampling distribution. So these are the 4 distributions, text messaging distributions. So we give them a wide variety. We give something that's approximately normal, something that's all over the place, something bimodal, and something skewed. And so the first thing, and the teachers don't get this picture, they just get a spreadsheet, basically, and then they have to get to this point of finding this. And then from that, regardless of what population they have, they go through this process of constructing an approximate sampling distribution. So here is a teacher's work for Jamal. So they constructed an approximate sampling distribution for samples of size 10, and that's what it looked like. I believe they took 200 samples. Size 30, and then this is what it looks like. And then size 50, and this is what it looks like. And then they're asked to comment on what happens to the shape, what happens to the standard deviation or the variation, and what happens to the center. And then they're asked to go back to their population and also make the comparisons with the population. So this activity, teachers in the second pilot were extremely surprised, and they had never seen it this drastically kind of put out. And also they were extremely happy that they were able to generate these on their own through simulation on software. And what happened was that through these types of activities, the second pilot results really indicated a drastic improvement in teacher understanding of the overall flow of the concepts. And the flow, in our opinion, is particularly important for a concept like sampling variability that has many important parts and applications. So I wanted to show you, or let you listen to an audio, a quick audio of one of the teachers explaining the learning trajectory. So this is at the completion of their activities. So now you can picture they've done 5 loops, 5 different activities, 5 open-ended assessments, and now they're asked to reflect on the whole entire thing together and what they've learned and what the big pictures are. So let me actually pull it from here.
Okay, some of the big ideas, the takeaways. The biggest one is the population distribution versus the sampling distribution versus the sample distribution.
Oh, shoot. Okay, sorry about that. I think I forwarded the slide too much. Okay, sorry. So that was the second audio. So let me give you, excuse me, let me give you one more audio first of the other teacher, and then we'll go back to that one.
So some of the big takeaways for me from the sampling variability learning trajectory was the different distributions, so sampling distribution versus sample distribution versus population distribution, and then also the idea of using one sample to make a formal conclusion. I originally thought that this was crazy when we were first doing the M&M activity, how do you use one sample, but so that was a major takeaway for me.
So I'll stop this teacher there. And so I thought we think it's very interesting. So basically when they start off in the loops, she doesn't believe that you can do anything with one sample. And through the progression of the activities and through the progression of the learning trajectory, she gets to a point at the end where she can construct a confidence interval and feel good about what she's done since she's done everything from scratch and understood the process. Now, and then I'll go to the second one, second teacher speaking in 1 second. So, and I'll close right here after this slide so we can open up the floor for questions. Presenting a topic such as sampling variability using a learning trajectory as a backbone can really provide teachers with a needed big picture. And this idea that you give them the learning trajectory after they've done all this process to pull it all together for them is quite helpful. This big picture is particularly important for teachers since they have to have a greater understanding of how everything fits together in order to teach it to their students. So if you can imagine going back to the Common Core, sampling variability shows up in 7th grade and sampling shows up, and it also shows up throughout high school. How can we figure out how to do a teacher preparation spanning all those grades? Well, one important thing is providing big picture progressions of how this topic extends throughout grade levels and how it's developed. The 7th grade level curriculum does not go all the way to confidence intervals. It's the high school ones that do. But if a teacher in high school doesn't understand where it comes from, then how are they supposed to just teach the confidence intervals, let's say, appropriately? So these learning trajectories, in our opinion, can give us the structure needed to deliver effective professional development for teachers. And I'm going to close with this last audio clip of another teacher explaining learning trajectory and her reflection on it.
Okay, some of the big ideas, the takeaways. The biggest one is the population distribution versus the sampling distribution versus the sample distribution. In using sampling distributions, my favorite one was the effective shape of population and the sample size on the sampling distribution. It doesn't matter what shape of the population distribution is, the sampling distribution gets normal as sample size increases. That's huge. And then the confidence intervals. So estimating a population parameter using sampling distributions and making a confidence interval.
Okay, and I'll stop her there too. So again, for this particular teacher, who actually was a teacher that has been teaching statistics several times throughout her life, and she is closer to retirement age, let's say, and she was struck by the fact that this all pulled together for her, and that had never happened for her. And so I think she was trying to go through these topics one by one. If I played the whole entire recording, you would see that this comes out. She had been used to sort of teaching these topics one by one, and she had never understood how they all were pulled together. And I think, and she also mentions that the use of technology and her ability to use technology in order to do this was such a fundamental change for her that she had never understood that could come into play. So I hope that this was informative for everybody, and I hope that we can, if people have questions and stimulate some conversation, that would be great, and I will leave it right there for Ellen to take over, I guess.
Okay, we have quite a few questions for you. Here's the first one. If you go back to where the actual standards were listed for grade 7 in the high school, they don't mention the word sampling variability explicitly. Why is that?
Great question. So, I think they do mention the words measures of, they do mention the word variability, and the 6th grade standards discuss specifically understanding variability. Now, when we float around sort of in these standards, there's all this idea of doing inference kind of starting to creep up, and this simulation, and then understanding the variability that happens in simulation. So sampling variability is there in the background. I don't know why we never use, the authors never use that term, but it's definitely there. I hope that answers the question.
Okay, here's another question. The course that you were describing with your pilot teachers, 15 weeks teaching statistics kind of course, is that for future or in-service middle school or high school teachers, or who were these people?
Good question. So these were, the 2 pilots were in-service high school teachers. So that was specifically the 2 groups that we had were all in-service high school teachers. However, I can imagine that pre-service teachers could take the exact same course, definitely, and especially the pre-service high school ones that are already math majors for the most part. And then for the middle school ones, the pre-service is a little bit different. It's tricky because the pre-service middle school teachers may be in that elementary group depending on how your state certifies. So it's sort of, the middle school pre-service is a tough crowd. But definitely the middle school in-service could take this. The way the topics are built up, they're pretty, when you're taking them through the progression, you can go very slowly to build up these concepts.
Okay. We have a couple questions that are related here. One is, what is the sample distribution? Because Google reveals nothing called a sample distribution, only a sampling distribution. And then another person follows up with, the terminology sampling distribution versus sample distribution is almost guaranteed to confuse people. Using names that sound more different would help a lot.
Yeah, absolutely. So I think we're all okay with population distribution. So a lot of times, especially in the elementary grades, students take, let's say, they only are given one sample, maybe, a group of things, and then they're asked to look at the distribution of that particular sample. So in other words, they would look at the distribution of kids in the class who were blonde versus brunettes versus redheads, etc. So that samples distribution is what we refer to as the sample distribution. So that terminology is not actually ours. That is terminology that's in a couple stats textbooks, intro stat textbooks, is those 3. And I want to say, I've got to look back, but I want to say it may also be in Gaze. So we don't actually go at it saying this is the population distribution, this is the sample, this is the sampling. But at different points in time, teachers and students are asked to look at those 3 distributions. And so what we call them depends on us. I totally agree. I don't think most people call it a sample distribution. But it's the distribution values in the sample.
Okay. Can you skip to the slides that had your example that you were working through?
Yes.
Okay. So somebody wanted to know if the red data was the actual data, and the blue data on another slide is a sample distribution from which
yes.
student?
Yeah, so these are the populations. So one of these dots represents let's say this is Sally's text message population. So one of these dots represents the number of text messages she received or sent out on one given day in the 3 years. So there should be 1,085 points on each of these.
Okay, and then on the next slide where you had the samples, which student's text messaging did that come from?
Jamal's. So is the bimodal one.
Okay.
Yeah.
Okay. And then more questions on this. What do you mean by samples of 10, 30, and 50? Are you talking about selecting 10, 30, or 50 days and counting messages, or selecting 10, 30, or 50 messages and seeing when they occurred, or something else entirely?
No, so the first one. So they have, if you can picture, the 1,085 days in their data set, and for each day they have the number of text messages they sent or received. So the teachers go in and take a random sample of size 10, let's say, of the number of texts they either sent or received, compute the mean, and plotted the mean for that. Put the sample back in and repeatedly did that 10 times, for every sample of 10, and they did it 200 times. Same thing for 30, same thing for 50.
Okay. And what technology was used to produce the various distributions?
Very good question. So the first time around in the first pilot, we were using Fathom, and then because Fathom is no longer available, we are using StatCrunch right now, which is has been actually working really, really well, and the teachers actually really enjoy it because it's web-based. This is a big issue for teachers with technology, and when they take it back to their own classrooms, they are in a bind. So if we use a technology that they can't have access to in their own classrooms in their high schools or middle schools, this is very problematic for them. So the idea that they can, their students could possibly have access to StatCrunch on their mobile devices or just their laptops without requiring a site license or anything like that, they can just pay that fee for the semester or whatever, or the year, has been really interesting that the teachers seem to really like that.
Okay. Are the teaching resources to be used by the classroom teachers well aligned to these learning trajectories? If not, do you think there will be a disconnect between what they learn using these, looks like PDs, and what they will end up teaching?
Great question. So in the materials, so let's say if you can picture one of these activities, so like for example this text messaging one right here, the way the lesson plan is structured is this activity is structured, it has all this front matter that follows sort of the STU lesson plan guidelines that guides the teacher of how they would do this with their students if they wanted to do it directly with their students. So the student versions, let's say, of these are quite similar, and they follow the trajectory almost identically as the teacher versions.
Okay. In the first audio clip that you played, the speaker mentions using one sample rather than multiple is enough to draw conclusions. What in the activity addresses this misconception?
Very good question. So the activity, the text message activity that I showed today, that we kind of briefly introduced today, is aligned with, let me double check before I say something wrong, the loop 3 of the learning projection. So if you have your learning trajectory open, here it is. So this is the text messages is aligned with this one. So you can see there's 2 more loops after it. And it's in the 5th loop that they go to the confidence intervals and they go to the one sample. So the question's completely correct that this particular lesson doesn't make that jump to one sample. What does is what's to come. So in loop 4 we started getting there because we're at well actually I'm sorry, no, it's really in loop 5 is where we get there.
Okay. And for our last question, can we get the actual lesson materials used to teach these lessons in the pilots?
Absolutely. So right now, and that is our goal. Our goal is to sort of produce these off the shelf where anyone can take them. And we're also very thankful for any comments. In fact, I don't know if Gary Cater's on the line, but I should say thank you to him because he provided some really valuable comments addressing some of these misconceptions that actually caused us to rethink certain things. But we'd love to hear a comment. So right now on our website, under our materials link, the website, you have the original versions. So these are the ones pre the 2 pilots. So they're not great at the moment, meaning we changed them a lot. Right now we're in the process of the 2nd pilot, and everything is starting to look really smooth. And so I would imagine that in the next 3 weeks or so, we have all the materials up and running, and I would be happy to send people a direct email if they want to email me directly to let them know when information's up on the website. But it should be there this summer for sure.
Is the link for the website, will that be on the CAUSE webinar page with your talk?
Yeah, well, I don't know.
Well, if you send it to us, we'll make sure it gets up there.
Yeah, and it's projectstat.com. It's pretty easy, and it looks
okay.
like this. So I can, and then the materials are right here under our materials. So you've got the learning introductory, the lesson plans, the professional development, the data sets available, and some of the videos, instructional videos that some of our undergraduates made that are part of the project. But again, these are the original materials. So right now, I would say this is all sort of under construction.
Okay. All right. Well, thank you, Anna, very much for this presentation. And I want to remind all of our listeners, first of all, that when you leave the webinar, there's a short survey to fill out that will give Anna and the CauseWeb staff some good feedback. And also, next Tuesday at noon, we'll have the JSE webinar, Engaging Students in a Large Lecture, an experiment using Sudoku puzzles. And you can go ahead and sign up for that if you'd like to be part of that webinar. Thank you very much, and I hope you have a good week.
Thank you.